I'm Miwa Messer. I'm the producer and host of Poured Over, and Siddhartha Mukherjee writes extraordinary books. Now, he also happens to be an oncologist and a professor. And you have two biotech companies now, which we'll get to at some point, but you also have a Pulitzer Prize. Let's start with the Pulitzer Prize for Emperor of All Maladies. The new book is The Song of the Cell. The subtitle is An Exploration of Medicine and the New Human. And I'm delighted to see you, but I got to ask about this new human part.
The new human is kind of a provocative idea in the book. I was obviously been toying with the idea of where medicine is going in the future and became really interested in the fact that, when you read historical documents, when you read about the first blood transfusion or when you read about the first time someone had a bone marrow transplant, they themselves, and of course their doctors and families, thought that what had come out of it was a new human being. When the first IVF baby was born, Louise Brown, she was broadly considered by the world a new human being, a new kind of human being.
Right.
Of course, there are hundreds of thousands of babies born with IVF today, and we don't, we sort of think of them as part of ourselves, normal process, et cetera, et cetera. But I wanted to highlight in this book, which is all about the excitement of being able to manipulate cells, that what we're really doing is tapping into a new conception of a human being in where we can manipulate ourselves through cells. And this is not going to be a sci-fi version. This is what I say, this is not Keanu Reeves in a black muumuu. This is ourselves. It is the birth of Louise Brown. It is the birth of astonishing therapies, which we are harnessing the immune cell, doing immune transplants in which you are living with someone else's body. You may be living with an altered version of your own body in the case of if your own cells, but the capacity to do gene therapy plus cell therapy, that combination has allowed us to sort of really begin to think of ourselves as humans or animals or organisms where we can manipulate fundamental units, blood, the immune system, bone marrow, potentially bones, potentially organs, potentially, parts of the nervous system, using a combination of robotics and gene therapy, but ultimately which impinge on how cells behave. And that's the new human part. And I find those new humans incredibly exciting. I find that, we, again, when think of the moment of Louise Brown's birth, everyone on Earth was shattered by her existence. And so I find these kinds of ideas very provocative. And that's the idea that in one of the provocations in the book is that, we're making these things, but what we're really doing is making a new conception of what it means to be human.
And gene therapies also have been around for a while, but they seem to have really progressed significantly in maybe the last decade. Do I have that right? Last few years, it sort of seems like, it's become much more common to hear someone say, oh, well, I don't have to do radiation. I don't have to do chemo. I'm actually doing something else. And that felt like sort of the last sort of hump. For those of us who don't work in medicine, it seemed like a very, very big deal.
One of the things also that I point out in the book is gene therapy is, of course, extraordinarily important. But before we conceive of gene therapy, really gene therapy is cell therapy. A gene is a lifeless molecule. A cell enlivens the molecule. And that's something somehow that I think a generation of observers or readers and writers, and perhaps even scientists have missed. In order for gene therapy to work, the gene has to get to the right cell at the right time, in the right place. And it's the cell that's the functionary of gene therapy. Without the cells. Now, part of the reason I think is actually there's something very metaphoric and iconic about all of this. And one of my reviewers pointed this out early on. DNA is an iconic molecule. It looks like, as someone said, it looks too perfect not to be right. When they saw the structure of DNA, the double helix, everything about the structure of that molecule looked too perfect not to be right. And of course, it was eventually proven right. But it's iconic. We see it. You pass by an advertisement for soap, and there's DNA. You pass by an advertisement for a skin product, and there's DNA, and there's a picture of DNA by it.
Right.
You go to the doctor's office, and there's a picture of DNA. And you could ask yourself, well, that's great, but this molecule is lifeless. It's a molecule in a test tube, just like sodium bicarbonate is. What brings this molecule to life?
Mm-hmm.
And it's the cell, and it does so in an extraordinary manner. In other words, if you read the genetic code, which you and I can, you could read it, but you couldn't understand it. It's the cell who understands it, and only the cell that understands it. You could read the genetic code, but you wouldn't be able to tell me, for instance, why certain organs look the way they do, why they behave the way they do, why aging happens the way it happens, why repair happens, which organs are reservoirs of stem cells, which can be genetically manipulated, how the immune system really works. You could read that whole code. The code is there, but we are blind to the code. Only our tiniest units are not blind to that code. And so in some ways, the cell is the icon, but it is so diverse in its function and form that you can't put it, in some ways you can't put it on the SkinCeutical advertisement. That's also a fascinating idea, is that we of course gravitate towards things that are so fantastically simple, but like DNA. But from that fantastically simple code, we're building these incredibly beautiful organisms, objects, the diversity of Earth. And there's no icon for them except for, of course, the cell.
Yeah, I want to build off of something that the New Yorker actually said in their review of Emperor of Maladies, which, we're going back a minute and a half here, but this is an enduring fault line in the nature of medicine itself. Is it a future-oriented science, or is it a present-rooted caring practice? And it seems to me that in your books, you're doing both of those things. You're saying, let's move the needle forward. Let's keep the science going forward and the therapies and the technology, but also never lose sight of the people. And that's not always the easiest balance.
Yeah, and I think, that making up that genre, as it were, I didn't find a writer in that genre. People write medical histories, people write personal case histories. I didn't want to do either. People write memoirs. I wanted to do all of them in the same book. And I wanted to do that without blurring the boundaries between any and all of those. So the book would become at parts a memoir, at parts a deep history, at parts a very narrow history. People are always interested in finding out, why are you so interested in what I was eating when I made the discovery? I'm always asking, well, what did the room look like? Where was it? Or sometimes, in the case of the gene begins to my visit with Mendel to Mendel's monastery. The Emperor of All Maladies begins with, to some extent, my stay at the Dana-Farber as a fellow, where I was training in cancer. So why am I interested? Because those are parts of, I consider those parts of living history. And by extension, I consider them part of the history of the whole. And I just meld them together.
And you've talked about how this is going to become a quartet, Emperor of Maladies, The Gene, and now Song in the Cell. And I'm wondering, it seems to me, having read all three, that Song in the Cell has a deep connection to both of the earlier books, not just for the reasons that you were talking about before, but that blend of the personal and the scientific and your research, and really just wanting to be honest about where you are and where you want to go.
Yeah, I think that, first of all, the honesty is very important. It's very appreciated. I think one of the things is that readers want to know where we are without sort of inflating the economy of knowledge in science, which is always a danger. We're so excited about what we're doing that we have as scientists, I think, as doctors, we have a slight tendency to inflate the economy of our own knowledge. I want the real picture. And yes, they're related. They're also, they're related in structure, they're related in form, they are related and in fact, in the end, when the quartet is completed, I think Emperor will be last in that quartet. The Gene will be first, the Cell will be second. The third book, which I haven't written, really sort of very vaguely started thinking about, will be the third, and Emperor will be the fourth. I think they're similar in structure, they're similar in form. What's interesting about them also is that they ascend in complexity. So the gene is the unit of life, but as I said, lifeless. The cell becomes the fundamental unit of living, and it enlivens the gene. Cancer is the pathology of that cell. And so it comes third or last in that trio or quartet, depending on how we think about it.
When did you start writing Song in the Cell?
I had a little hiatus. I was writing a lot for the New Yorker and the New York Times Magazine. So I had a little hiatus in terms of my writing so let's say from 2017 to 18 and early days of 19, I had a hiatus in terms of writing a book. I was writing a lot, but I wasn't writing a book. And then sometime, I think early 2019, late 2018, I began to realize that in fact, this was material for a book. And that's probably when I started. I don't have an exact date.
Yeah. You write sort of in 5-year chunks, it looks like.
Yeah, I write in about 4 or 5 year chunks.
Yeah, okay. You have an active practice here in New York.
I do.
As an oncologist. You also teach. Where is this coming in? How are you making the time? I mean, back in the day, you used to sort of lock yourself in the office and grab 5 minutes here, 10 minutes there, 5 minutes here. Is that still how you're doing it? I mean,
yeah, I'm locking myself in my office for longer times. I mean, the companies are interesting because they're I would say, very cutting edge. One of them is a public company called VOR, which is trying to cure leukemia using gene therapy and gene editing. It's really one of the first times that we've gene edited this particular gene in history. And so there's a lot of excitement, but a lot of trepidation around, how it'll go. And things have been going very well for VOR. I've been involved in a company that is regulating diet to manipulate cancer. Again, a paper we published in Nature 3-4 years ago. And then in India, I've set up one of the first CAR T-cell company. We've dosed about 10 patients. And that's also been very exhilarating to watch. So, but those companies sort of run on their own once I've founded them. I just sort of keep the lead on the research team. I don't do any of the administrative work. I just take a step away from that. And then, of course, the medicine goes on as it goes on. And so I find stretches of time. I'm not a very disciplined person. I just find stretches of time. And then the trouble is getting yourself into the zone. But once I'm in the zone, I can pull out, 20, 30, 40 pages a day, sometimes even more. I could write an entire section. And that's how I've always written. That's how I always write. I'll go back and maybe check out half of it later. But when I pick up speed, just in terms of putting words on the page, I put words on the page. And
you've said in earlier interviews, too, that you don't really differentiate between your work as a doctor and your work as a writer. And I'd really like to take a minute and explore that idea for a second. I mean, I think at a very base level, I understand what you're saying.
I think, there's several ways that I come to that idea. One of them is I use, like many people, I use writing to think. And I use diagrams and writing together to think. It is my mechanism of how to think through problems, think through medicine, So that's the narrow sense. But the broader sense, I also use it to think about not just one case or this particular case. I use it to think about the landscape of medicine. Doctors often don't ask questions like, where are we now and where are we going? They're sort of, we're so nose to the ground, which is a good thing. You don't want your doctor to be the local philosopher. But we're so nose to the ground that we often sort of forget the idea that there's a journey here, and it's a remarkable journey, one of the most remarkable journeys in intellectual history. And so, I just think of the landscape. Where is the landscape? Where are we going? And that's why, again, this whole question of, human and new human, what are the limits and what are the implications for all of this? So obviously there's some separation between my writing life and my medical life, but I'm on the page as a doctor. That makes a big difference again.
So where are we now?
Well, first of all, we're learning, very broadly speaking, how an organism is built, how an organism repairs itself from injury, and how an organism performs rejuvenation over time and longevity. I would say that's a very, very broad landscape view of where we are. Cells are the functionaries in all of this. Cells are reading the genetic code and then converting that genetic code into function. Once we figure out those three, how we're built, how we repair ourselves, and how we rejuvenate ourselves, and their flip sides. So what makes that building go wrong? What makes the repair go wrong? And when you cannot rejuvenate or rejuvenate too much, you get cancer or death from degenerative diseases. So we're trying to look at both the building and the destruction, the pathology that accompanies when those processes go wrong. I think once we understand them relatively deeply, they don't have to the fullest depth. The question that we're asking and we're beginning to ask is, well, okay, we understand this. Can we change it? Can we change the process? And can we change it deliberately, safely? What are the limits of that safety? And how do we control those changes? So, for instance, we're beginning to work with T cells in a way that didn't exist in my prior lifetime. We're beginning to work with the bone marrow. For instance, at VOR, we're changing the bone marrow in a way that was impossible to imagine. So it's the combination of this knowledge of these sort of very three broad categories combined with cell manipulation and genetic manipulation. Cell manipulation meaning isolation of cells, identification of the cell type, and genetic manipulation of that cell type. And then beginning to create, build up organs, build up organ systems, build up, reboot the immune system, cure really deadly diseases like cancer, moving into diseases like type 1 diabetes. We're trying to transplant, pancreatic beta cells that they'll secrete insulin so that you don't need to inject yourself every day. This is part of where we are.
Yep. And the book is where we're going.
Exactly. So as we find out more and more about these three processes, we'll find out more and more about where we're going. And sometimes in some cases, we're sort of almost halfway there. In other cases, we're a quarter of the way there. And yet other cases, we are far from there. The march is going on. We're in the middle of it.
When you talk about gene editing and gene splicing, and people have very big feelings on coming from different angles on it, and it still sounds a little science fiction-y, even though you're a doctor and you've been practicing for a number of years. And then you've also got this sort of little specter of eugenics in the background. And I mean, you talk about both of these things in the book, and it really is like, how do we put the science first? I mean, you talk about science being the search for truth and how exciting it is to be on the frontier of creating a new medicine. I mean, these are all important things, but we don't always have the greatest track record as humans when it comes to applying these things.
That's something that scientists need to realize. I mean, that was in some ways very central to the gene and is somewhat central to this book. There's no regulatory authority that's going to tell us what to do and how to do it, when to do it. If you're living in China or in Russia or in somewhere else, different rules apply. But I think the idea of eugenics is very much part of it. I mean, the hard line that people have drawn so far is, what I call the line of suffering. Is it suffering? It should meet an unmet need. In other words, it should meet the unmet need of suffering, and then have safety and a track record of safety. Then there are, as they're complicated. Things become, in the real weeds, things become complicated. There's a very interesting section in this book where, the American Society for Gynecology meets and says infertility isn't suffering. We've had infertility for, the beginning of human history. So it's not suffering, whereas obviously, I don't think that would be the consensus today. Therefore, they said IVF shouldn't be treatment. If you're not treating, what are you treating? What is the medical condition you're treating? It rings very oddly today because we are so on the other side of that. It seems like an absurd statement, but at its time, it was not considered absurd. Lots of people really believed it. And so that's an example of how sort of even though we can be relatively strict and honest about what suffering means and how we can handle it. I think that the term itself is slippery and moves along and often can't be just pinned down.
Yeah, you also tell a personal story about a bout of depression you had in 17. And you're talking to an old friend and colleague, Paul Greengard, who had a really interesting way of looking at depression. And I just want to raise it here because, again, there are some people who are just like, well, it's brain chemistry. He called depression a slow brain problem. And then the two of you sort of dissect it over lunch. Can we go there for a second? Can we talk about Paul and his slow brain?
Paul unfortunately died in 2019, I think. But Paul was an immense figure in his field, a towering scientist. And he won the Nobel Prize in 2000 for physiology and medicine. And that Nobel Prize is really important in our understanding of diseases like depression. So, for years and years, so we have to go back a little bit. So the nervous system obviously is made of neurons, nerve cells. And there were classic experiments performed in the 1950s in which they solved how nerve cells talk to each other. That mechanism of talking was an electrical impulse moves through a nerve cell. And we can talk separately about how that exactly happens, but you can imagine an electrical impulse that moves through a nerve cell. When it reaches the end of a nerve cell, it causes the release of chemicals called neurotransmitters. So those chemicals are like serotonin, dopamine, a chemical called GABA, many others, the whole families of them. Those chemicals then go into this little tiny little cleft, little space between the two neurons, one wire just finished. They go into that space in between the two wires, and then they restart the electrical impulse in the second wire. They may be inhibitory, they may be excitatory, but they do something to the second wire and change its electrical transmission. And this process occurs in about a millisecond. And this is the so-called electrical brain. And it was very soon called the fast brain because the whole process occurred so quickly. So this was the conception of the brain as a series of wires with this chemical neurotransmitter thrown in the middle, but nonetheless a series of wires. And the idea was that if we solved the black box of wires, we'd solve all the problems and our understanding of the brain. So consciousness, sentience, sensation, all these other memory, all of these other features of the brain would be solved by understanding the wired brain, the box of wires. And as I said, there's a chemical thrown in the middle. From that emerged a theory of depression, which was that the chemical thrown in the middle, serotonin, there wasn't enough of it. And therefore, if you somehow could increase that chemical, you would relieve or alleviate depression. I call this the loudspeaker theory. So it's because, it's like, you've got two electrical wires, but the loudspeaker between them or the volume of transmission between them isn't high enough. It's not sparking enough signal in the second neuron, the second electrical wire. And if you could just make it a little bit louder, the second wire would become, could now hear it, and it would resume normally. And so in the 1970s and 80s, many drugs, Prozac and Paxil and other drugs were invented. These are serotonin reuptake inhibitors, SSRIs. The bottom line is what they do is they increase the level of serotonin in your brain. And the idea was that, once you've restored if you've increased the amount, then the electrical brain will now restart or respark in its normal process. And as it resparks, your depression will heal. That happened in some cases, but the responses were far from predictable and far from universal. Paul comes in here at around the 80s and 90s, and he says, wait a second, there's a different kind of transmission going on in the brain. And it's very important, this different kind of transmission. The brain is not just a bunch of electrical wires. The brain is also a site for biochemical reactions within the cell. So when that impulse from one cell appears down and binds to the receptors in the second neuron, in the second electrical wire, it's not like just sparking off another electrical signal. What it's doing is it's changing fundamental biochemical, metabolic, physiologic features of the second wire. And so don't think of the brain as a box of wires. It is also a site of biochemical reactions. It's a chemical. His idea was that it's this slow transmission, which occurs on the orders of seconds, if not days, changing the electrical wire at the recipient end, that really are responsible for many properties of the brain, and most importantly, are dysfunctional in diseases such as depression and schizophrenia. And Paul, to the end of his life, believed that depression was not just a serotonin, not enough serotonin problem, that it was actually changes in the slow brain, changes in the biochemical pathways that ultimately cause this mood disorder. So that's sort of the big distinction.
But that also leads you to a Carl Sandburg poem. I mean, this is something you do throughout all of the books, that you have as many literary references as you do medical references. It's a really great Sandburg piece that you pull, but Zadie Smith shows up in this book. Iris Murdoch shows up in the new book. And so your influences are so obviously coming from every piece of your life. But can we talk about the writers for a second, the writers who helped shape you? Because you've said it before that I learned to write by reading. And when I say write, I mean write really beautiful, smart books, not just,
Well, the first thing I'll say is that whenever I have a conversation with someone, I mean, they know that I'm a writer, and I might be having a scientific conversation. And I'll say to them, just remember, nothing is really off the books. In other words, when you say something to me, if it happens to catch some thread that is deep, that will probably end up in a book somewhere. You may be anonymized, the phrase may be changed around, but it'll end up somewhere. It's going to become part of the broader thinking. The other question that people ask me is I find it a little annoying, but it's important to answer. They often say, do you write a book and then go backwards and find poems and fit them in? And that's obviously not the case.
No.
You couldn't write a book like that. If you're a real writer, you can't write a book like that.
Right.
But what I do is when I'm writing, so if I'm writing this piece on depression, and I'm sitting there and remembering, and I often just know the scratch of the poem. I have to look up the actual words on the internet. It's not, I memorized 1,000 of them. I'll know the scratch of a poem, and I'll say, there was something so beautiful in that image of this cat who sits quietly on haunched feet and won't go on. And the reason I think of this is that I used to have a cat, now I have a dog, but often in the morning I'll get up with the feeling of extreme chest heaviness, and it's because one of those two animals is sitting on my chest. And so I had this image, and I couldn't shake the image of like some kind of organic animal sitting on my mood, not letting it rise, like pressing it down. And that's how the Sandburg poem came in. Zadie has been an old friend of my wife's, and has written about my wife. So I read Zadie's first book long before I even knew her. But I love Zadie as an essayist, and there was something about reading way back when I was reading about that essay. That this is an essay that Zadie writes about Dickens and about the ability. So it's actually a very powerful essay. It's about whether or not we can whether or not we can transform ourselves into other characters. It's a very radical essay particularly for this time. When there's a strong question about who can write about what, very controversial, tough topics, and there's been a lot of conversation about this. Zadie takes up this idea of Charles Dickens writing about Little Nell. And she says, and I found it very interesting, she says, look, there's an infinitude of curiosity in that moment. It's not like Charles Dickens feels as if he's sort of schizophrenic. He has an infinitude of curiosity in that moment. And when I read that, I said, that's very interesting, because it's a little bit like science, because in my lab, there's no hard and fast rule that we cannot work on something. And the analogy isn't perfect. Labs don't have the same sense of identity. They don't have the same history, and history is not loaded, et cetera, et cetera. But what I found interesting is this idea of a person, Charles Dickens, being surrounded by all the characters he's created. And in the lab, and sometimes I think, I'm sitting there surrounded by all the experiments that I've created, some in blood, some in leukemia, some in metabolism, some in, we study, one of the things that as is in the book, is that we study bone. And we've discovered many, many things about bone that have nothing to do with blood or cancer or me being an oncologist. It's just that we went down that rabbit hole and found really incredible things about bone and bone biology. So therefore, that image from Zaidi was very, very haunting and came into the book. What other influences? I mean, they're quite standard. Some of them are standard, classical Victorian case studies that I learned how to think about or think through via people like Oliver Sacks. How to string a narrative together chronologically, how to be in the place that I learned from Richard Rhodes, The Making of the Atomic Bomb. Atul Gawande's books, obviously, about sort of humanizing case histories and making them present. Jenny Egan's sometimes satiric and absurd sense of humor. I don't know, I can keep quoting, non-scientific and literary references which come into the book.
And I think it's important too, because what you're trying to do is bring people to a subject that not everyone is always rushing to. I remember the first time I read Emperor of Maladies, and I thought, wait a minute, who is this guy and what's he doing? And I knew you were a doctor, and I knew I wanted to read the book because I'd heard so many good things from wildly different people in my life saying, oh, have you read this? Have you read this? And I sat down and I probably read it pretty quickly. I do remember, because you're a little bit of a page turner for a science writer. And I just remember thinking, oh, I don't think I've ever seen anything like this before. And I've been a bookseller for a really long time. And it was one of those moments where it's like, and then the gene came and I was like, okay, I'll follow you down this rabbit hole too. And here we are with Song of the Cell. And I don't think you can have what you do if you aren't pulling influences from disparate spaces. I don't
think so. It'd be a very boring book.
Right?
It's also an experimental book in terms of structure. Usually people write books in chronologically. This happened and that happened, and then she did this and then this happened. That's a story. And it's a great friend. It's a great friend in terms of writing a book. In the Song of the Cell, I started a chronological, and certainly the first few chapters are. And then I take this, I think, a weird and radical departure. And then I say, well, you know what? Every chapter is going to be a cell. I was struggling to put it all sort of into one chronological basket, historical basket. And I said, one day I woke up and I was like, you know what really this book wants to be? This book wants to reflect that the development or the history of cell biology is a non-chronological history by itself. Lots of things are happening at the same time. So you can't say, you'll be in 10 places at the same time following 10 different leads. But the body is a separate unit of organization. The body has organs and systems and cells, and those cells perform separate functions. So I said, well, what if each chapter is a cell? Let's just try it on. And that's when I wrote the first chapter on IVF called The Dividing Cell. And all of a sudden I was like, that feels very natural, because you can then go on from the dividing cell to another functional property. And in the end, you get a sense of how all of these functional properties build up to create humans. And if their function goes wrong, you get disease.
One of the things you talk about too, though, you needed to add a little new material that you hadn't quite planned on, because you said there's no way to write about the cell if you're not going to write about COVID.
I had already started the book. There was quite a lot that had gone into it. Um, and then the pandemic began to wildfire its way through the world. And I was basically homebound for a while. I would see some patients, but in a very limited capacity. And this was when it was at the worst throes of the pandemic. And then I began to realize that even the pandemic is really a kind of extrapolation of cell biology. You can't think of the pandemic outside cell biology. And so we began to realize that that is really the way that cell biology, and it's also, as I say in the book, also a very humbling moment, because it was all of a sudden we realized that aspects of cell biology that we don't even know. I don't know how many people know this, but one reason, not the only reason, but one reason that young men who were previously healthy have had such a severe reaction to COVID, or rather SARS-CoV-2, the virus, is because they already had a pre-existing, unknown, unrecognized autoimmune disease, which had really inactivated one of the ways that the body responds to viruses. And they had gone along their lives perfectly normal, nothing abnormal about their lives. But this virus all of a sudden exposed the idea that that was the problem. That autoimmune disease was the problem. And we wouldn't have even known that it was an immune problem until we dissected the cell biology and the immune biology of our human responses to SARS-CoV-2.
When it comes to studying science and being involved in the sciences, I think everyone there is clear that, like you said, you don't always know, but the whole point is to find out. It's harder to follow science sometimes when you're not in the thick of it, and it's harder to understand that it is a little bit of a moving target. You have to make educated guesses to get to the next step, and sometimes it really works, and sometimes it doesn't. But what's the biggest lesson you took away from Song of the Cell? How did writing this book change you?
I think the biggest lesson was to understand. Again, I think that's why the COVID chapter is very crucial. Was to understand again what the landscape looks like. Build, repair, rejuvenate. But how much is now unknown? Emperor Maladies in some ways was a sobering book. The Gene was a book where you felt a sense of, I would say, a mixture of excitement, but also of anticipation about the future. I think this book, you feel the excitement, but you also feel as if you don't know what you don't know. So in some sense, I think this book is a humbling book. It's a book about sort of realizing that we need to understand, as I say in the last chapter, not just the cell in isolation, but the cell in its context, the cell, what I call the ecology of the cell. And it's only when you see and understand that ecology is when you really begin to figure out how things work and why things work the way they do. All books have moods, and I think the mood of this book is exactly that. There's a sense of excitement about what's being done, but there's also a sense of humility about sort of, how much we don't know.
The one thing I can't really stress enough, I know you're talking about humility in Song of the Cell, but it's an incredibly hopeful book. I mean, you're standing on the precipice of the future, and you're managing it in a way that not everyone gets to and not everyone gets to see. So can we just talk about that for a second? Because I think it's really important for people to understand that, like, the future's here.
Yeah, the future's here and the future is ours. And it's just, what was to me the most interesting thing about writing this book was the sense of excitement.
Yeah.
And being there and doing this, looking down. There's so much of this book which is about looking. You keep looking down microscopes, looking down tunnels, looking at lenses, looking at everything. And that looking is also, of course, a looking into the future. It takes on an abstract form, a metaphorical form. So I just, I found writing this book intensely exciting. And And I kept saying, why hasn't anyone written this book before? Um, and obviously, that people write different books, but this is a moment. I met Emily Whitehead, one of the first survivors of T-cell therapy in Pennsylvania, and I was like, again, it was sort of like my Louise Brown moment, in which I said, you're alive because some group of scientists working over decades really figured out what a T cell was, figured out how to take a T cell out of the body, weaponize it with a gene therapy weapon, basically, grow those T cells in a petri dish in a laboratory in a sterile manner, infuse them back into your body, and make sure that the T cell would eat the cancer, not eat the rest of you. That's all you. Now, each step seems like a throwaway line, but was dug out of hard, cold earth in terms of science, but also is so exciting. We're talking about real monumental things here. Monumental ways to change the body, monumental ways to, as I said, make new humans. And so I guess I just wanted to convey that excitement that I hope, sort of palpates through the whole book.
Yeah, you need story to make the science sing.
Yeah.
That's really all it comes down to. So,
like the song of the cell.
Exactly. Siddhartha Mukherjee, thank you so much. Song of the Cell is out now, along with, of course, Gene and Emperor of All Maladies. Thanks again.
Hello, readers. It's time for another TBR Top Off, where we recommend books to pick up when you stop in for your copy of The Song of the Cell. I'm Mark, and I'm coming to you from my Barnes & Noble store in Cincinnati, Ohio.
And I'm Madison, coming to you from my store in Indianapolis.
We've got a couple of great books to cover today. Madison, if you don't mind, I'll jump right in.
Go ahead.
So I chose a fantastic book called Mountains Beyond Mountains by Tracy Kidder. This is a remarkable and inspiring story about Dr. Paul Farmer. This man, this extraordinary, glorious, wonderful man, about 40 years ago, he established a health clinic in one of the poorest parts of Haiti. He specialized in particular diseases like tuberculosis and AIDS. His work extended through Haiti, reached through Peru, and even as far as Russia. And all of this good work is still felt today. And it stems from the mind and heart and philosophies of this beautiful, beautiful man. He believed that hard work and a kind heart were the first necessary components for healing. Secondly was access and resources. And he strove every moment of his life to achieve all of those pieces. His commitment and his courage are boundless, and his empathy should be forever recognized and emulated and celebrated. Sadly, Dr. Farmer died earlier this year, but his legacy lives on in this book and in the thousands of lives that he helped to heal. If you need a great pick-me-up, please check out Mountains Beyond Mountains by Tracy Kidder. Madison, what do you have for us?
I think what I want to point out first is that what our books have in common is kind of like the heart that's at the center of all this good work that all these doctors, surgeons are doing, which is why I chose The Facemaker by Lindsay Fitzharris. It was recommended to me by our bookseller Heidi here at our River Crossing store, and it is about the surgeon Harold Gillies, who was at the foundation of the plastic surgery movement. And I think when we think of plastic surgery today, you think more like of vanity, people getting all sorts of trying to make the wrinkles go away off your face, maybe a nose job because you had a bad fall when you were a child, all these different things. But I think what's wonderful about this book is that you actually get into the history and how it started kind of wasn't that way at all. It all was centered around the First World War and these soldiers who came back from war and needed facial reconstruction surgery. So what Gillies did was kind of give this spirit, hope, and humanity back to these soldiers. So what he did when he got his victims who were badly burned, missing pieces of their faces, he reconstructed it for them so society no longer saw them as monsters, but the heroes they deserve to be. And I think that is such an important message to spread and something you might not think about when you think of plastic surgery today. which is why I think The Facemaker by Lindsay Fitzharris is such an interesting and inspiring read when you get down to it.
Fantastic pick, as always. Well, that is all we have for today. Thank you so much for tuning into Poured Over. Please make sure to give us a rating and subscribe so you never miss an episode. You can follow us at Barnes & Noble, pretty simple. I'm Mark. You can follow my home store at BN Westchester.
And I'm Madison. You can follow my home store at BN River Crossing.
Thanks, everybody. Happy reading.
Happy reading. Bye-bye.
Poured Over is a Barnes & Noble production. The show is available on Apple, Spotify, and Stitcher. Please rate and review us wherever you listen to podcasts.